Hey everyone, this is Atman and welcome to my final report presentation for systems engineering on AI-driven security systems, that is a case study on CrowdStrike Falcon. So as you remember from last time that I discussed, CrowdStrike Falcon is I think a world-renowned cybersecurity tool which is used to deter cyber attacks from various nefarious actors, which is used and deployed by various businesses for their computing solutions deployed worldwide. Now, this digital age has ushered in an era where data is both a critical asset and a significant vulnerability for organizations worldwide. Cybersecurity has evolved from a niche concern to a central pillar of organizational strategy, driven by the increasing frequency, sophistication, and impact of cyber threats. As cyber criminals develop more advanced techniques to exploit vulnerabilities, the limitations of traditional security methods such as signature based detection have become increasingly apparent. Organizations now face threats that exploit zero day vulnerabilities, employ polymorphic malware, and leverage AI and machine learning for malicious purposes. CrowdStrike Falcon actually stands out as a leading example of a real time AI driven security system designed to address all these challenges. It is a cloud native endpoint protection platform that integrates AI, ML, and behavior analysis to provide continuous monitoring, detection, and response to threats. Unlike traditional security solutions that rely on predefined signatures or rules, CrowdStrike Falcon uses advanced algorithms to analyze patterns of behavior and anomalies all across the network, enabling it to detect and neutralize both known and unknown threats in real time. So, this report actually provides kind of a comprehensive analysis of the development, deployment, and post deployment stages of CrowdStrike Falcon. It covers many more components actually, so it details each phase of systems lifecycle, the systems engineering challenges faced, and the methods possibly used to overcome them. The report also explores the effectiveness of AI and ML in enhancing cybersecurity defenses and discusses the lessons learned from the implementation of this advanced security system. Also, at the end of this report, we will kind of also address the infamous CrowdStrike incident that occurred earlier this year, somewhere in July 2024. Now, if we take a look at the chart provided by CrowdStrike themselves, we can actually see the fair share of cyber attacks all across various continents, where you can kind of see the insights based on the malicious activity going on all across the world and across various industries. So this data kind of suggests that North America has been the prime target of, let's say, most of the cyber attacks out there, followed by Europe and Asia. And also, if you take a look at the industries targeted, most prominent ones were technology, telecom, and financial, followed by government and retail. Now, let's take a look at the background of the evolving cyber threat landscape. Cyber threats have become increasingly diverse and complex in recent years, driven by technological advancements and the growing interconnectedness of digital ecosystems. As organizations adopt cloud services, IoT devices, and remote workforces, they face a broader range of vulnerabilities and attack vectors. Understanding the nature of these evolving threats is crucial to developing effective cybersecurity strategies. Now, if you look at the APTs, that is the advanced persistent threats, So APTs are like a type of cyber threat is which is characterized by prolonged and targeted attacks designed to infiltrate networks, steal data, and remain undetected for extended periods. These threats often involve multiple stages, including reconnaissance, initial compromise, lateral movement, and data exfiltration. APTs typically target high value assets such as intellectual properties, financial data, and confidential information. Detecting and mitigating APTs require advanced techniques that can identify subtle patterns of malicious behavior over time. With zero-day vulnerabilities, zero-day vulnerabilities are previously unknown software flaws that attackers exploit before the vendor can issue a patch or update. These vulnerabilities are particularly designed because there is no prior knowledge or signature available to detect them. Zero-day attacks can cause significant damage, and detecting them requires systems capable of recognizing abnormal behaviors even when no known signature exists. AI-driven security systems such as our CrowdStrike Falcon uses behavior analysis and anomaly detection to identify potential zero-day attacks. With polymorphic and metamorphic malware, it changes its code or appearance each time it infects a new system. So that kind of makes it difficult for traditional antivirus software to detect. Metamorphic malware takes this kind of like a step further by completely rewriting its code while maintaining its original functionality. So these techniques allow malware to evade detection by signature-based security solutions. Now, to combat these type of threats, these AI-driven systems must focus on detecting behaviors and patterns rather than relying solely on the static signature. Now, supply chain attacks actually target the software or hardware components provided by third-party vendors. By compromising these components, attackers can gain access to an organization's network bypassing traditional security measures. Supply chain attacks are particularly challenging to detect because they exploit trusted relationships and often involve legitimate software updates or hardware modifications. AI and ML based solutions can help identify unusual behaviors or anomalies that may indicate a supply chain compromise. Now, actually, if we do notice, we did kind of see an infamous supply chain attack, kind of that took place in the Middle East. So this is kind of exactly that. Now, with the ransomware attacks, now they have actually become very increasingly prevalent and sophisticated, often targeting organizations with critical data or operations. These attacks involve encrypting data and demanding a ransom for its release. Modern ransomware can propagate rapidly across networks, exploiting vulnerabilities in various systems. Now, these AI-driven systems are kind of essential for detecting early signs of ransomware attack, such as unusual file access patterns, data exfiltration attempts, or unauthorized encryption processes. Now, if we kind of have a look at the overview of Falcon, so it's basically a cloud native endpoint protection platform that addresses these evolving threats by leveraging a multi-layered AI-driven approach to threat detection and response. The platform combines advanced machine learning models, behavior analysis, and a cloud-based architecture to provide comprehensive cybersecurity coverage. Now, with its cloud native architecture, so basically the cloud native design of CrowdStrike Falcon enables it to scale across multiple environments from small businesses to large enterprises without the constraints of on-premises infrastructure. This architecture allows for continuous updates, rapid deployment, and the ability to analyze large volumes of data. The cloud based approach also enhances the platform's ability to detect threats across geographically dispersed networks, providing a unified view of potential threats. With behavior analysis and anomaly detection, so basically, Falcon employs machine learning models to establish baselines for normal behavior and detect deviations that may indicate malicious activity. Now, by analyzing user behavior, network traffic, and system activities, the platform can identify potential threats in real time. For example, if an employee begins to start accessing sensitive files outside of normal working hours or attempt to connect to restricted servers, the system will flag this behavior as suspicious. With the machine learning models, now CrowdStrike Falcon utilizes supervised, unsupervised, and reinforcement learning models to detect both known and unknown threats. So these models are kind of trained on extensive data sets containing examples of legitimate and malicious behaviors, allowing the system to recognize patterns associated with the different types of attacks. Now, the platform's AI-driven approach kind of enables it to adapt to new threats as they emerge, providing a proactive defense against evolving attack techniques. Now, if you look at the integration with existing security tools, so basically the platform integrates seamlessly with existing security tools such as firewalls, intrusion detection systems, and security information and event management solution, that is the SIEM. Now, this integration kind of enables organizations to leverage their existing infrastructure while enhancing their overall security posture. Now, with combining the strengths of different tools, Falcon provides a multi-layered defense against a wide range of cyber threats, which is kind of amazing, to be honest. Now, with the real-time threat intelligence, basically Falcon actually continuously updates its threat intelligence database with information from various sources, including its global network of sensors, threat research teams, and external partners. This real-time intelligence helps the platform stay ahead of emerging threats and provide security teams with actionable insights to protect the networks. Now, let's take a look at how CrowdStrike Falcon comes into action. So, in this demonstration, the quarantine write-on policy configuration is kind of switched off to kind of demonstrate how Falcon actually kicks in during the event of a cyber attack, let's say. So here, let's say, for example, an adversary does like a brute force attack and drops 4 malicious files. That is, okay, so it's basically it drops 4 files, out of which 1 is a legitimate file and 3 are the malicious ones, out of which 2 are discovery tools and 1 is a ransomware. So when these files are released onto the system, right, that is obviously because we let it. So obviously since we have Falcon at our disposal, these files will not actually cause any harm. So how this takes place is basically once the adversary releases these 4 files, after we deliberately let them in here, so our Falcon response is kind of activated and it kind of blocks the discovery tool run. And what Falcon now does is that obviously thanks to its AI capabilities, it has, first of all, it has blocked the attack based on the detection of the malicious files by itself. So what it does is it opens a control panel, uh, it uh, it releases out, it gives out the Overwatch alert, and basically notifies all stakeholders that the attack is taking place, and it basically like deflects off these malicious tools, and because the attack is prevented, the adversary finally exists without causing any harm, thanks to CrowdStrike Falcon. All right, now if we take a look at the concept development stage, we can first focus on the needs analysis phase, where we have kind of identified the needs. So basically, we have first the real-time threat detection. So basically, the need for this is actually critical in today's cybersecurity landscape. Now, traditional security solutions often kind of rely on batch processing or post-incident analysis, which delays response times and increasing the potential for damage. In contrast, real-time security systems like CrowdStrike Falcon continuously monitor traffic, user behavior, and system activities to detect threats as they occur, enabling organizations to respond immediately. Now, real-time monitoring involves continuously collecting and analyzing data from various sources, including endpoints, network traffic, and user activities. This enables the detection of anomalies and potential threats as they occur, reducing the time to detect and respond to incidents. Also, the automated detection and response capabilities are actually really essential for reducing the burden on security teams and minimizing the impact of attacks. Now, by leveraging AI and machine learning, Falcon can automatically identify and respond to threats such as isolating compromised systems, blocking malicious IPs, and notifying security personnel. Now, if we take a look at adaptability and continuous learning, so here, as you can see, like cyber threats kind of evolve rapidly, with attackers frequently developing new techniques by bypassing traditional security measures. Now, these AI security systems must adapt to these changes by continuously learning from new data and refining the detection algorithms. Now, Falcon uses ML models that are trained on diverse data sets, including both known and unknown threats, to improve their ability to identify emerging attack patterns. So, with adaptive learning, it actually involves updating the machine learning models to reflect new threat intelligence and emerging attack patterns. This ensures that the models remain effective in detecting new threats even as attackers change their tactics. Now, Falcon employs automated model retraining techniques to incorporate the latest threat intelligence into its detection algorithms. Now, Falcon also uses behavior analysis to understand the context of user actions, network traffic, and system activities. By analyzing these behaviors in context, the platform can distinguish between legitimate activities and potential threats. Like, for example, the system might recognize that the user is accessing sensitive files as part of the job role rather than as a part of a malicious attempt to exfiltrate data. Now, with scalability across diverse environments, so with the growing adoption of cloud computing, IoT devices, and remote workforces, now cybersecurity solutions must be able to scale across multiple environments. CrowdStrike Falcon is designed to protect endpoints across different network architectures, from small businesses to large enterprises, and across various device types, including servers, desktop, mobile devices, and IoT endpoints. Now, the cloud native architecture of Falcon kind of enables it to scale across multiple environments, providing consistent protection regardless of the size or complexity of the network. This scalability is achieved through the use of cloud resources, which allows for rapid deployment, continuous updates, and the ability to analyze large volumes of data. Now, it also offers flexible deployment options, allowing organizations to choose the deployment model that best suits their needs. The platform can be deployed as a fully managed service in the cloud or as a hybrid solutions that integrates with the on-premises infrastructure. Now, with compliance and data privacy, now if we kind of look at all the organizations out there, they must all comply with the range of data protection regulations such as GDPR and CCPA, that is General Data Protection Regulation, and the California Consumer Privacy Act. Now, real-time AI security systems must balance the need for robust security with compliance requirements, ensuring sensitive data is protected while maintaining privacy standards. Now, Falcon incorporates data protection principles into its design, ensuring data privacy is considered at every stage of the development process. That includes minimizing data collection, implementing strong encryption process and access controls, and providing transparency about how data is used. The platform is also designed to comply with a wide range of regulations like GDPR, CCPA, and all other various global privacy laws out there across the world, across various different regions. Now, Falcon also provides tools and features helping organizations meet their compliance regulations such as data masking, anonymization, and logging. Let's now take a look at concept exploration with AI and machine learning techniques. Now, with supervised learning models, they are trained on labeled data sets containing examples of legitimate and malicious activities. In CrowdStrike Falcon, these models are used to detect known threats such as malware, phishing attempts, and ransomware attacks. The system analyzes a wide range of features, including file hashes, IP addresses, and URL patterns to classify new data points and identify potential threats. Now, in this, we have feature selection and engineering. So basically, feature selection kind of involves identifying the most relevant features for detecting threats, such as the frequency of failed login attempts, the volume of data transferred, or the number of connections to external IP addresses. Feature engineering involves creating new features that capture important patterns in the data, such as the ratio of successful to failed logins or the average duration of network connections. Now, there's also a component of model training optimization. So here, the supervised learning models are trained on large data sets containing examples of both legitimate and malicious activities. Training involves adjusting hyperparameters such as learning rate or batch sizes to optimize model performance. These models are regularly retrained with new data to ensure they remain effective against evolving threats. Now, with unsupervised learning models, they are employed for anomaly detection, identifying deviations from normal behavior that may indicate new or unknown threats. Now, techniques like clustering and outlier detection help to identify anomalies that do not match predefined rules or signatures. Now, anomaly detection involves identifying patterns in data that deviate from the norm. Now, Falcon uses algorithms such as k-means clustering, BB scan, and GMM models to detect anomalies in network traffic, user behavior, and system activities. And to improve the efficiency and accuracy of anomaly detection, Falcon could also use dimensionality reduction techniques such as PCA and T-distributed stochastic neighbor embedding, TSNEs, to reduce complexity of the data while preserving the important patterns. Now, with behavior analysis, Falcon continuously monitors user behavior, network traffic, and system activities to establish baselines for normal activity. The platform uses machine learning models to identify deviations from these baselines, flagging potential threats for further investigation. One of the important components here is user and entity behavior analytics, that is UEBA. Now, this is a key component of CrowdStrike Falcon's behavior analysis capabilities. The platform uses ML models to analyze the behavior of users, devices, and entities within the network, identifying anomalies that may indicate malicious activity. Now, there is also contextual analysis happening here as well. Now, that kind of involves understanding the context of user actions, network traffic, and system activities. Like, for example, the system might recognize that a user is accessing sensitive files as a part of the job role rather than like part of malicious attempt to exfiltrate the data. Now, with reinforcement learning models, now this allows Falcon to learn from interaction with the environment, adapting to its response tactics based on the outcomes of the previous actions. This approach enables the system to optimize its performance over time by refining its detection strategies. Now, reinforcement learning involves assigning rewards or penalties to different actions based on their outcomes. For example, the system might receive a reward for correctly identifying a threat or a penalty for generating a false positive. This feedback loop helps the system learn which actions are the most effective in different scenarios. Reinforcement learning also involves balancing exploration with exploitation. Falcon uses algorithms such as Q-learning and deep Q networks to optimize balance, ensuring that the system continues to improve its detection capabilities over time. Now let's take a look at the system architecture. Now let's first take a look at the data collection and the pre-processing module. Now this module is responsible for collecting data from multiple sources such as network traffic, endpoint sensors, and user activity logs. Data pre-processing involves filtering noise, normalizing outputs, and extracting relevant features for analysis. For example, the system might remove irrelevant data points, standardize timestamps, and convert raw log data into a format suitable for machine learning models. Now, with the AI-based threat detection engine, now this is the core component of Falcon, the threat detection engine. Utilizes supervised, unsupervised, and reinforcement learning models to analyze data in real time. The engine continuously monitors for anomalies, suspicious behaviors, and known threat signatures, flagging potential threats for further investigation. For example, the engine might detect an unauthorized user attempting to access sensitive files and immediately triggering an alert. The incident response module. Now, this module automatically triggers alerts and responses when a threat is detected. The response actions may include isolating compromised systems, blocking malicious IPs, and notifying security personnel. For example, if a system detects malware on an endpoint, it can automatically quarantine the affected device to prevent further spread. Now, with the dashboard and the reporting interface, now with Falcon, there comes a real-time interface for security analysts to monitor network health, to review detected threats, and manage incident responses. The dashboard includes visualization tools such as graphs and heat maps to help analysts quickly identify and prioritize threats. For example, the dashboard might display a heat map of network traffic, highlight areas of concern based on threat levels. Let's now focus on the engineering development, especially the AI model development. Now, the development of AI models for Falcon involves several stages, including data collection, pre-processing, feature engineering, model selection, and training. The models are designed to detect both known and unknown threats using a combination of supervised, unsupervised, and reinforcement learning techniques. Now, with data collection and pre-processing, here data is collected from multiple sources, including network traffic, endpoint sensors, and user activity logs. Pre-processing involves filtering out noise, normalizing inputs, and extracting relevant features such as file hashes, IP addresses, and URL patterns. This step is critical to ensuring that the data used for training is accurate and representative of real-world scenarios. With feature engineering, it involves selecting and creating features that are most relevant for detecting threats. For example, features might include the frequency of failed login attempts, the volume of data transferred, or the number of connections to an external IP address. Feature engineering is a critical step in developing effective machine learning models as it determines the quality and relevance of the input data. Now, with model selection, training, and optimization, the models are trained on large datasets containing examples of legitimate and malicious activities. Training involves adjusting hyperparameters such as learning rate and batch size to optimize model performance. The models are regularly retrained with new data to ensure that they remain effective against evolving threats. Now, with model validation and testing, now in this, the models undergo rigorous validation and testing to ensure that validate their accuracy and effectiveness. This includes cross-validation, where the models are tested on multiple subsets of data and testing against real-world scenarios to evaluate their performance in detecting various types of threats. Now, like I reflected in the last section, PCA, TSNEs, and deep Q networks are critical components for dimensionality reduction and reinforcement learning during the model training process. With integration and testing, they are actually the critical stages in the development of Falcon. The system must integrate seamlessly with the existing security tools and infrastructure such as firewalls, IDS, and SIEM solutions. Now, with integration with security tools, now Falcon actually integrates with existing security tools to provide comprehensive threat detection and response capabilities. For example, the platform collaborates with firewalls to block malicious IPs and prevent network-based attacks. Integration involves developing custom APIs, plugins, or connectors that enable communication between CrowdStrike, Falcon, and other solutions. With testing and validation, the system undergoes rigorous testing and validation to ensure its effectiveness. This includes both functional testing to verify the system performs as expected and non-functional testing to evaluate its scalability, performance, and reliability. Testing is conducted in both simulated and real-world environments to ensure that the system can handle complexities of real-world networks. And with security testing, it involves evaluating the system's ability to withstand attacks such as penetration testing, vulnerability assessments, and threat modeling. This testing helps identify potential weaknesses in the system and ensures that it is robust against various attack vectors. Now, with the real-time threat detection, CrowdStrike Falcon actually employs a range of real-time threat detection and response mechanisms to identify and neutralize threats as they occur. So here we have first the real-time monitoring, where the platform continuously monitors network traffic, user behavior, and system activities to detect threats in real time. Any deviation from established baselines are flagged for further investigation. Real-time monitoring involves the use of advanced algorithms and analytics to detect subtle patterns and anomalies that may indicate malicious activity. In an automated response, Falcon can automatically respond to detected threats by isolating compromised systems, blocking malicious IPs, and notifying security personnel. Automated response capabilities are critical for minimizing the impact of attacks and reducing the time to respond to incidents. Now, with adaptive learning, the platform continuously learns from the new data and the feedback to improve its detection capabilities. For example, the system might adjust its detection threshold based on the outcomes of previous action, optimizing its performance over real time. Moving on to post development stage. If we now look at the deployment strategy, the deployment of Falcon actually involves several key steps to ensure a smooth transition from development to production. We have pilot testing, where before full deployment, the system is tested in a controlled environment to identify any potential issues and optimize performance. This includes testing the integration with existing security tools, validating the effectiveness of the AI models, and evaluating the system's capability. Now, with phased rollout, the deployment is here kind of carried out in phases, starting with a small subset of endpoints and gradually expanding over to cover the entire network. This approach allows for incremental adjustments and it minimizes the risk of disruptions. User training and support. Security teams are often trained on how to use the system, interpret alerts, and respond to incidents. Ongoing support is provided to ensure that users are comfortable with the new platform and can effectively leverage its capabilities. With the post-deployment maintenance, Falcon ensures that there are regular updates, continuous monitoring, and iterative improvements happening on the system to deter future threats as time goes by and threats evolve across the time. Moving on to the systems engineering challenges. First, let's take a look at the scalability and integration. CrowdStrike Falcon actually must be scalable to protect diverse environments, including cloud on premises and hybrid networks. The system should adapt to various levels of complexity and scale to meet the needs of different organizations. Now, it has a cloud on-premises integration where it kind of signifies that the platform must seamlessly integrate with both cloud-based and on-premises environments, providing consistent protection across all endpoints. And it also has a component for resource allocation where it kind of ensures that system can actually scale without overloading resources. And that is a very critical aspect of this. Now, this may involve deploying additional computing power, storage, and network bandwidth to handle increased demand. Now, if you look at the data privacy and compliance sections, we are kind of ensuring that that the compliance regulations are always in place. Real-time monitoring must be designed to protect user data and maintain privacy standards while effectively detecting threats. Now, there are ethical considerations and transparency issues. Now, there is a responsibility of Falcon to make sure that there is enough transparency in AI-based threat detection and is kind of essential to build trust amongst users and stakeholders. Now, Falcon must employ explainable AI techniques to provide clear, understandable explanations for its decision detections. And also, transparency is key to building user trust and ensuring accountability. Now, this is something I believe they are kind of working on and which is not publicly available in that great of a detail, but that is actually the challenge of most of the companies that is now deploying AI in the real world nowadays. Now, with handling false positives and negatives, Reducing them is critical for maintaining trust in the system. Now, implementing adaptive learning techniques that allow system to adjust its decision thresholds based on feedback from security analysts can help reduce the system false positives. Now, with advanced contextual analysis, it actually helps improving systems' ability to analyze context, such as relationship between users, device, and network segments that can help reduce false positives, which can greatly affect future threat detection mechanisms for CrowdStrike Falcon. Now, moving on to basically the elephant in the room. So, let's discuss a bit about the recent outage occurred due to CrowdStrike's software. Now, even though there are many takeaways from their AI development, model development, and scaling strategies, we also have to take a great look, we have to do a detailed analysis into this outage as well to understand the systems engineering components even better with this case study. So, on 19th of July 2024, now CrowdStrike experienced a critical incident due to a faulty update on its Falcon censored software. This event caused significant disruptions across industries, impacting approximately 8.5 million Microsoft Windows systems globally, such as, there are sectors affected, such as aviation, healthcare, and finance-based operational breakdowns due to system crashes, highlighting critical vulnerabilities in the interconnected systems. Now, for context, CrowdStrike's Falcon sensor is actually a lightweight software agent deployed on endpoints such as desktops, servers, etc. to detect, prevent, and respond to security threats in real time. It is a critical component of the CrowdStrike Falcon platform. So basically, it is like a lightweight version of CrowdStrike Falcon itself. So basically, now what this section will do is kind of examine the outage that occurred from a systems engineering perspective, focusing on the root causes, systems affected, and possibly, I think, key lessons that we can derive from this. And the key lessons that we can derive from this based on, as an example for the real-time AI security systems out there. So yeah, now this image actually shows the negative effect that the outage had all across the world. So basically, all the airport systems which showed flight details, baggage details, all of them were jammed because of this single fault, which caused massive, massive losses to various airlines and various stakeholders who were involved with deploying the software. So this was, I would say, probably a watershed moment in CrowdStrike history. And to resolve this, I think there was significant investigation done. And the issues were fixed accordingly, but issues like this shouldn't have happened in the first place. So let's just take a look at the summary of everything we've discussed so far and the lessons that we have learned and CrowdStrike learned based on this incident that happened. Now, the key lessons that we kind of learned are comprehensive testing and validation. Now, the importance of the rigorous testing and validation cannot be overstated. The CrowdStrike incident revealed deficiencies in regression testing and edge case analysis that led to widespread disruptions. Moving forward, organizations must adopt more robust testing protocols and ensure compatibility across diverse configurations and operating environments. The misconfigured kernel file at the heart of the outage emphasized the need for more stringent configuration management practices. Maintaining accurate baselines, automating configuration validation, and enforcing strict change controls are essential to avoid similar failures. Now, building resilient systems is also a key lesson that we must take from here. Even though CrowdStrike may have their own set of redundancy measures in place, but they were not enough to avoid a catastrophe of this scale that happened. So, like, the lack of redundancy that we saw here and failover mechanisms in affected systems kind of highlight the need for designing solid resilient architectures. By incorporating layered defenses and isolating potential failure points, organizations can actually ensure continuity of operations even during system outages. Now, with enhancing incident responses, the extended recovery time during the CrowdStrike outage demonstrated the value of proactive incident response planning. Developing predefined recovery protocols, automating rollback mechanisms, and improving monitor tools can significantly reduce downtime and mitigate the impact of future incidents. With proactive risk management, conducting regular failure mode and effectives analysis, that is the FME assessments, is kind of essential for identifying and mitigating risks before they materialize. Adaptive learning and dynamic risk assessments can further enhance systems' ability to anticipate emerging threats and respond effectively. Now let's see the broader implications this has for systems engineering. Now, this outage has broader implications for systems engineering security practices and cybersecurity. Now, with interconnected system vulnerabilities, we see that organizations must recognize the cascading effects of failures in highly interconnected environments. Systems must be designed with interdependencies in mind to prevent single points of failure from causing widespread disruptions. Now, with operational scalability and complexity, we see that as real-time AI systems become more sophisticated, maintaining operational scalability without introducing additional complexity is a critical challenge. Simplifying integrations and employing modular architectures can help address this issue. Now, for possibly having recommendations for future developments, what we can do to avoid similar incidents and enhance the reliability of these AI systems, we can kind of focus on these proposals, that is, investing in advanced testing capabilities, where we leverage automated testing frameworks for continuous validation of updates. We can simulate diverse environmental conditions to account for variability in real-world deployments. We can adopt a resilience-first design approach, where we can integrate failover and redundancy mechanisms into system architectures designed for graceful degradation to maintain partial functionality during failures. Now, we can also strengthen proactive risk management frameworks such that we can establish adaptive learning systems that can evolve based on emerging risks. and incorporate real-time risk assessment to prioritize mitigation efforts. And finally, we can focus on enhancing user training and communication, where where it can provide comprehensive training for users and administrators on incident response processes, and we can maintain clear and transparent communication channels during outages to build trust and manage expectations. Now, finally, as I conclude, I must say that the CrowdStrike outage was a stark reminder of the challenges involved in deploying and maintaining real time AI driven security systems at scale. While such incidents expose vulnerabilities, they also offer valuable lessons that can drive innovation and improvement in system engineering practices. By addressing the challenges highlighted in this report and implementing the recommended strategies, organizations can build more robust, resilient, and secure systems to safeguard against the ever evolving landscape of cyber threats. Thank you for listening and see you next time.